What if the entire universe has been playing us for fools? What if everything we thought we knew about the beginning of time, the birth of galaxies, and even the laws that hold reality together, was based on a misunderstanding? Because right now, the James Webb Space Telescope, the most powerful eye humanity has ever opened to the cosmos, is quietly unraveling the fabric of the universe. And scientists are officially stunned. This isn't just about spotting pretty galaxies or snapping space selfies. It's about discovering galaxies that shouldn't exist, stars that are too old to be that young, and cosmic structures that are too organized to be random. Something's wrong. Or maybe something's finally right. Because the more we look, the more it seems like the universe has been hiding its true story. And now, for the first time in history, we're starting to read between the lines. When astronomers peered into the deepest reaches of the cosmos using James Webb, they expected to find chaos. Tiny, unformed, young galaxies struggling to ignite their first stars. What they found instead were behemoths. Galaxies so massive and well-organized that they seemed ripped out of the middle chapters of the cosmic timeline, not the beginning. Some of these galaxies, like the infamous MOM Z14, formed just 280 million years after the Big Bang. A blink in universal time. And others may be even older. This isn't just a surprise. It's a cosmic contradiction. These galaxies aren't fragile, chaotic clouds of gas. They're structured, spinning, glowing with mature stars like cosmic veterans. According to everything we thought we knew, they shouldn't exist. It's as if we expected to find a newborn and instead found an elder with a full beard and wisdom in his eyes. James Webb isn't just seeing further than ever before. It's seeing deeper. And what it's showing us makes our entire timeline wobble like a tower of Jenga pieces waiting to fall. To explain why galaxies don't fly apart like glitter in a breeze, scientists invented dark matter, the invisible duct tape of the cosmos. It doesn't shine. It doesn't speak. And it doesn't interact with light. But it has gravity. And we believed it was the silent architect that kept galaxies together for billions of years. But now Webb is exposing cracks in that belief. If dark matter is supposed to slowly shepherd galaxies into form, how do we explain fully formed galactic giants just hundreds of millions of years after the Big Bang? They didn't just grow, they leapt into existence, like skipping the baby steps and jumping straight into adulthood. Either dark matter behaves in ways we don't understand, or worse, maybe it doesn't exist the way we think it does. Webb isn't just observing space. It's interrogating the very foundation of modern cosmology. And dark matter is suddenly looking more like a suspect than a savior. In physics, we rely on constants, fixed numbers that help us measure, predict, and build our understanding of how the cosmos behaves. But recently, scientists have been wringing their hands over two critical ones, the S8 and the Hubble constant. When we look at the early universe through the cosmic microwave background, we get one number for how clumpy matter should be. But when we look at today's universe, we get a different value. That's the S8 tension. It's like measuring a child's height at age 5, then again at 20, and realizing the numbers just don't add up. The Hubble constant, which tells us how fast the universe is expanding, is also throwing tantrums. Depending on how we measure it, past or present, the numbers refuse to agree. It's not a rounding error. It's a red flag waving in the face of modern physics. The more data Webb provides, the clearer it becomes. The universe is telling us two different stories. And now scientists are asking the most terrifying question of all. What if both stories are wrong? If the Big Bang is the cosmic origin myth, the sacred beginning, then the cosmic microwave background, CMBB, is its fingerprint. For decades, we believed this faint afterglow was the echo of the universe's birth cry. But now, even that is under fire. Webb's deep space imaging suggests that some of what we've been reading as the CMBB might not be a primordial signal at all. It might be the accumulated light of ancient galaxies, tightly packed and redshifted beyond recognition. If true, this would mean the cornerstone evidence for the Big Bang is contaminated or worse, misunderstood entirely. And it gets stranger. The telescope recently observed 30,000 galaxies, most of which are spinning in the same direction. According to the laws of physics, the early universe should have been chaotic, random, full of tumbling and twirling galaxies. But what Webb found was order, alignment, a cosmic choreography that hints at something far more structured, something that may have had a plan from the start. And just when you thought things couldn't get weirder, some physicists now suggest we may be living inside a black hole. That's not a metaphor. That's the actual hypothesis. The event horizon, that's the edge of our observable universe. Our Big Bang, not the beginning, just the other side of a cosmic bounce. If that's true, then everything, our time, our space, our physics, is wrapped inside something much bigger and possibly not alone. Among the many surprises James Webb has delivered, one has left astrophysicists speechless. The discovery of stars that seem older than the universe itself. Let that sink in. Some of the stars James Webb observed in early galaxies appear to be so evolved, so heavy with metals that they shouldn't have had enough time to form, burn through fuel, and spread heavier elements so quickly. These are not first-generation stars. They are ancient, chemically enriched giants, glowing defiantly in a universe that shouldn't have had time to build them. It's as if they skipped steps in stellar evolution, appearing fully formed like actors walking on stage before the play has even started. And if the stars are older than the timeline allows, then either the Big Bang occurred much earlier than we thought, or we're misunderstanding time itself. What if time isn't linear? What if the universe has loops, folds, or echoes? James Webb may not have just discovered stars. It may have cracked open the concept of cosmic time itself. Zoom out far enough and the universe begins to look like a web. Galaxies clumped together along vast filaments stretching across unimaginable distances. But Webb is now showing something even stranger. Repeating patterns, unusual alignments, and massive structures like the giant arc that defy the expected randomness of cosmic expansion. This isn't just unexpected. It's forbidden by the cosmological principle. The idea that on a large enough scale, the universe is homogeneous and isotropic. No preferred directions, no preferred places. But these structures challenge that principle. They seem organized, deliberate, designed. Imagine stumbling across a massive spiral staircase in the middle of a forest. It doesn't belong, and yet it's there. That's how physicists feel when they look at these megastructures. And the more Webb maps the cosmos, the more this hidden order emerges. Could we be missing the real shape of the universe? Are we trapped in a kind of cosmic scaffolding, unaware of the geometry that's guiding it all? As Webb reveals galaxies and structures never seen before. Another disturbing question is rising in physics, one tied not to space, but to the very act of observation. Quantum mechanics tells us that particles behave differently when observed. Webb is now detecting light that has traveled billions of years across spacing to reach us. But here's the unsettling part. Those photons only chose their path when they interacted with our detectors. In other words, the universe until we look remains in a state of probability. If so, what is the telescope really doing? It's not just revealing the cosmos. It's collapsing it into reality. That's the mind-bending power of observation. Some physicists now argue that the universe, or at least its structure, may not even be real until something observes it. Webb, therefore, is not just a passive viewer. It's an activator. What if the universe becomes more real the deeper we look? And what if some parts of it don't want to be observed? In its deepest scans, James Webb has detected a faint boundary, an edge beyond which light seems to dim unnaturally fast, as if hitting a wall. It's not the limit of technology. It's not cosmic dust. It's something else. Light is behaving differently there. Red shifts beyond that point don't match known models. Some theorists whisper about the cosmological horizon, but others are more daring, suggesting it's an artificial limit. That beyond that point, reality itself may not function the way we expect. Could we be inside a simulation, a finite chamber of controlled spacing? One physicist described it like this: Webb may be bumping into the edges of the code. It's an outrageous idea, but what if it's true? What if James Webb's real discovery isn't a galaxy or a nebula, but the end of the rendered world? We built the James Webb Space Telescope to answer questions, to reveal the unseen, to map the early universe like a cosmic archaeologist unearthing the bones of time itself. But what if we built it not to find answers, but to awaken better questions? Because every image it sends back doesn't just illuminate the cosmos. It challenges our sanity. Galaxies that shouldn't exist. Stars older than time. Structures too perfect to be random. Boundaries that behave like walls and a silence beyond the edge that feels less like emptiness and more like design. What if the universe isn't an accident? What if it's a system? And what if James Webb is the first eye to truly see the gears turning beneath the surface of space? The most terrifying thing isn't that we've found too much. It's that something out there knows we're watching now. Do you think James Webb is just revealing space or unraveling reality itself? Let us know in the comments. If this discovery stunned you, share this video because people need to realize that the universe may not just be expanding, it may be responding. Hit that subscribe button and turn on notifications because this is just the beginning. Next time when Webb peers even deeper, it might uncover something we were never meant to see.